Most AI projects fail not due to a lack of technology, but because people don't know what they're trying to solve. This book isn't written to praise artificial intelligence. It's written for those standing amidst a colossal wave of data, knowing that technology can change the world but still wondering where that change will lead us. The author doesn't promise technical miracles, but guides readers on a very different journey, a journey of awareness. Here, AI is no longer a learning machine but a test of humanity's capacity to learn. From the very first pages, Velko Crini introduces a simple yet perplexing paradox. The more data organizations have, the easier it is for them to lose direction. This is because data only tells us what is happening, not why it is happening. AI can predict the future, but it cannot tell us what in the present is truly worth changing. The problem isn't with the technology, it's with the intention. Do people truly understand what they want to learn? In a world where every click is recorded and every action becomes data, AI acts like a giant mirror reflecting all of humanity's behavior. But the frightening thing isn't that the mirror is too intelligent, it's that it's too honest. It doesn't judge, it merely repeats. If we are chaotic, it will double our chaos. If we are wise, it will amplify our wisdom. The real question isn't whether AI is intelligent, but whether we are wise enough to teach it the right things. Succeeding with AI doesn't teach programming, nor does it talk about neural networks or optimization techniques. It talks about a way of thinking. The author once worked with large corporations where hundreds of millions of dollars were poured into AI projects, with the only result being a few scattered charts. From this, he drew a truth: AI cannot save an organization that doesn't understand itself. If a business doesn't know the value it's pursuing, every algorithm becomes meaningless. What's notable is that instead of exposing failures as technical errors, the book reveals them as failures of perception. When a group of engineers excitedly talks about 99% accuracy, while the leadership asks how much it increases profit, we see not a disagreement but two groups living in different linguistic worlds. And AI only succeeds when these two worlds find a way to communicate. This isn't a how-to guide, it's a mental map for the data age. Each chapter opens up a new layer of thought: how to choose the first project without burning through capital, how to connect technical work with business value, how to understand the soul of a machine learning pipeline instead of just chasing the superficiality of algorithms. It makes readers realize that building AI is like planting a garden. Not every seed will sprout, but if just one survives and blossoms, the entire plot will transform. Behind what seem like dry examples and concepts lies a subtle yet powerful message. AI doesn't replace humans. It compels humans to become smarter to deserve coexistence with it. When technology can learn faster than anyone, the only thing that anchors humanity is the ability to understand the meaning of data, to understand our own limitations, to understand why a decision is right or wrong. The book concludes with a quiet premonition. One day, AI will be present in every corner of life. Then, the question will no longer be whether we should use it, but which part of human nature we want it to reflect. That question, once asked, is not just for managers or engineers, but for anyone living in this era. Therefore, when opening Succeeding with AI, what you're reading isn't just about technology, but about humanity's intelligence, limitations, and ethics in the age of machine learning. And perhaps the most important question each person will carry after reading is: if a system can learn from all our behaviors, what is the first thing we want it to learn? Over years of working with organizations, big and small, I've witnessed the same story repeat itself in countless variations. A group of leaders believes that by simply pouring data into an AI system, results will miraculously pour out. They imagine technology can replace thinking, that algorithms can make decisions instead of humans. Then, after millions of dollars and countless months, they realize the only thing the system delivers is a thick report filled with numbers no one knows what to do with. The failure of these AI projects isn't technical, it's because people forget themselves. I call this the age of implementation, when the world no longer needs to discover new laws, but must learn how to turn existing knowledge into practical action. It's like the era when humans knew how to generate electricity, but still needed centuries to learn how to light up cities. AI is no longer an invention, it's a challenge of application. In this phase, Success doesn't come from scientists passionately writing papers, but from those who dare to connect data with real-world practice, who dare to let technology serve a purpose rather than replace humanity. Many have told me that the formula for success is simple: data plus AI equals money. But the harsh truth is that this formula is often only correct if money is understood as cost. To truly turn data into profit, we need another component I call clue, human insight when acting on understanding derived from AI. Data and algorithms are merely soulless pieces. It's the profound insight, the ability to connect results with specific actions, that creates value. Without clue, the entire system is just an expensive machine spinning aimlessly. I once compared AI to a large ship. It can run on wind, on waves, with sails full of data. But if the helmsman doesn't know where they're headed, that ship will merely circle in the fog. Technology can never replace direction. In the projects I've witnessed, the difference between success and failure lay in whether leaders truly understood the question they wanted AI to answer. Many failed to define what action would follow the results. And so, even if the model ran perfectly, the business still didn't know what to do next. When I asked a management team at a large company what they would do if the system predicted customers were about to leave their service, the entire meeting room fell silent. They had never considered a specific action, only being fascinated by the idea of prediction. That is the most common mistake of the implementation era. People are so busy searching for answers that they don't have the right questions. Data doesn't lead the way on its own, it only reflects what we are wise enough to ask. The truth is, in any project, there are countless technical choices: which platform, which model, where to store data. But if we spend most of our time on those choices and forget the project's raison d'etre, everything becomes meaningless. The most important thing isn't how good the technology is, but which human question it is used to solve. Every time a team starts by debating which infrastructure to use, I know they're headed in the wrong direction. They're building a bridge without knowing what the two riverbanks are. A principle I constantly reiterate is to start with actionable steps, not with tools. Never ask, what can we do with this data? But rather, what can we change in the real world? If you cannot envision the final action, all analysis is wasted. AI does not create value. Human reaction to the results is the real value. Many leaders tell me they want to delve deeper into the data to find something interesting. I just smile. There's always something interesting in data, but most of it has nothing to do with business. Once, a research team found that customers in the North bought more coffee on Wednesdays than on Fridays. They gleefully reported this as a major discovery. I asked, "So, what will you do with it?" No one could answer. Analysis without action is a cost, not an investment. The world of AI is full of temptations. It makes us believe we can disregard emotions and experience, that data alone is enough. But experience is still what dictates direction. An organization can hire the best experts, build the most cutting-edge systems, and still fail. Simply because they forget a simple truth: real value doesn't lie in the algorithm, but in the ability to turn results into concrete decisions. AI is merely a mirror, not a seer. And that is why I wrote this book, to recount the costly lessons hundreds of businesses have learned, to point out that in a world enveloped by the glamour of technology, what humans need to relearn is the art of asking the right questions, choosing the right actions, and measuring the right value. AI doesn't demand more belief, it demands sobriety. Only when we truly understand its limitations can we genuinely use it to expand our own. Looking back at the early years of the data era, I realized a paradox. The more data there was, the easier it was for people to get lost. They thought they were making evidence-based decisions, but in reality, they were drifting in a sea of numbers without knowing where to anchor. That's precisely when clue is needed, something that cannot be programmed, bought, or outsourced. It can only come from experience, from the ability to see through the numbers to the human beings behind them. When understood this way, AI becomes an ally. It's no longer a threat nor a miracle. It's just a powerful, precise tool, but it still needs human hands to guide it. And only when we know where we're going will the wind truly carry the boat in the right direction. There's one thing few people acknowledge: AI isn't intelligent in the way we imagine. It doesn't understand the world, has no concept of meaning, and certainly doesn't know what's right or wrong. It merely optimizes a number that humans set. It repeatedly performs soulless calculations to make that metric smaller or larger. If humans choose the wrong metric, the entire system will exert itself to achieve something meaningless. I once told a management team that they were training AI like a diligent but naive student. They taught it to memorize formulas, made it calculate faster, but forgot to tell it why it was calculating. The result was a perfectly running model, but no one understood what it was optimizing. AI is merely an optimizer of numbers. Humans are the ones who define goals. When these two roles don't meet, the project is bound to fail. To understand better, we need to look at AI from 3 angles: problem formulation, optimization, and evaluation. First, formulation. Humans must find a way to interpret a business problem into a data format that the system can process. Next is optimization, the machine's part, where algorithms run like cold, emotionless rivers. Finally, evaluation, where humans must return to verify whether the results truly reflect business value. A machine cannot inherently know what success is, it only follows predefined formulas. It's at this evaluation step that I've seen many businesses stumble. They use academic-sounding metrics like root mean square error, accuracy, and confidence, but no one on the executive board understands what those numbers mean for profit or customers. I used to advise them, don't tell me what the MSE is now, tell me how that number changes profit. When leaders don't ask that question, they're letting the data ship drift without a compass. Technical metrics have no value if they aren't linked to business metrics. A business might achieve 99% accuracy in predicting buyer behavior, but if they don't know how to act on that prediction, the number is just an illusion, like a beautiful map that's useless without someone to navigate it. AI doesn't create value. Human action creates value. Therefore, every analysis must begin with the question, what will we do if the result is X? If there's no clear answer, the project should stop immediately before wasting more time and money. I recall a project in Europe where an analysis team spent half a year just trying to find something interesting in the data. They drew hundreds of charts, exploring all kinds of correlations. Finally, they discovered that customers in the North bought more bread on Monday mornings than on Tuesday mornings. This finding was documented in a 70-page report. I asked, "So, what will you do with this information?" They were silent. I told them if the only action was to print more charts, this wasn't discovery but waste. Data is only meaningful when it leads to real-world action. Another paradox is that humans often demand AI explain causes, yet they themselves rarely understand why they act. AI doesn't find causes, it only detects correlations. It says 2 events often happen together, but doesn't know which leads to which. It's like seeing smoke and fire and concluding that smoke creates fire. That's the most common illusion when people attribute reasoning capabilities to a system that doesn't possess them. When I brought this up in a meeting, a leader responded, "We need to know why customers are abandoning our product." I replied, "AI can only tell you they have left and the common characteristics of that group. As for why, that's a human question. It is precisely in the gap between data and cause that human intuition and experience become invaluable." AI predicts what will happen, while humans must understand why. In reality, many organizations get caught up in dazzling reports, believing that more data will lead to correct decisions. But the more data there is, the greater the potential for error, especially if there's a lack of ability to discern what's truly important. Data has no ethics, no priorities. It obeys any question we ask, even the wrong ones. Once AI starts optimizing for the wrong goal, it will do so with such proficiency that it destroys the business itself. That's why I always tell development teams that before running any model, define true business metrics, not just revenue, but specific, actionable measurements the organization can react to. This could be customer retention rates, complaint resolution time, or profit-to-cost ratios. If you can't measure the impact, you can't manage it. In the world of AI, where emotions are replaced by figures, the right numbers become the only language of persuasion. But metrics can also betray you. One business once rewarded employees based on the number of customer emails answered. They worked diligently, replying quickly. But no one noticed that service quality sharply declined when the metric itself became the goal. It no longer measured anything meaningful. Similarly, when AI is trained with the wrong objective, it will achieve that objective at all costs, even if it runs counter to the true interests of the business. True insight is the ability to set the right metrics. This is a human skill that cannot be delegated to a machine. It demands understanding of the organization, of customers, and of the limits of the technology itself. A leader might not know how to program, but if they deeply understand what truly creates value, they can steer an AI team in the right direction. The successful one isn't the person with the strongest algorithm, but the one who knows how to ask the right questions. The more powerful AI becomes, the more humans must relearn how to think. Technology makes us feel like we know more, but in reality, it only exposes the shallowness of our problem formulation. It's not AI learning from us, but us learning from its reflection, learning to see the limits of our own intelligence. And perhaps that is the deepest value of the data era, forcing humans to be humble, sober, and to realize that no line of code can replace the ability to understand real life. There's a question that has always haunted me throughout my years of working with businesses. When AI is ready, what will people do with it? Most answers I receive are vague. They talk about potential, opportunities, innovation. But few clearly state what the specific actions will be. Without action, all technology is meaningless. I've seen organizations invest in colossal data analytics systems only to realize they had no one willing to make decisions based on those numbers. AI is merely a mirror reflecting a reality. People don't know what they want in the business world. AI can be used in many different ways, and understanding these distinctions is key to success. Sometimes it's a decision support tool, sometimes it's a component of a product, sometimes it's a process automation system, and sometimes it is the product itself. A hospital might use AI to assist with diagnoses, helping doctors review thousands of similar cases. A tech company might embed AI into its application to predict user behavior. A factory might use it to automate quality control steps, and a startup might build its entire business model around a single algorithm. Regardless of the form, the principle remains unchanged. AI only delivers value when humans know how to act on its results. A product recommendation model will be meaningless if the marketing team doesn't change its promotional approach. A predictive maintenance system won't save a production line if the engineers don't trust the warnings and fail to perform timely maintenance. Technology can open possibilities, but humans themselves must walk through that door. I remember once being invited to consult for a large medical center. They had implemented an AI system to aid in cancer diagnosis, inspired by world-renowned projects. After 2 years, the project halted. Despite spending tens of millions of dollars, the reason wasn't that the system was flawed, but because no doctor used its results to make actual decisions. There was no bridge between humans and technology. The project died prematurely. They invested in a tool but forgot to invest in the trust and processes surrounding that tool. The strange thing is, the more organizations talk about AI, the fewer truly understand what problem it's solving. They want it to appear modern, to impress investors, to avoid being left behind in the race. But AI isn't a fashion statement. It's a tool that demands discipline and patience. Whenever a company adopts AI merely out of fear of falling behind, they've started with fear instead of purpose, and fear is never the foundation of innovation. When I speak with leadership teams, I often ask, if your AI disappeared tomorrow, what would happen to your company? The answer reveals a lot. If they say, we'd be paralyzed, I know they're overly dependent on machines. If they say, it's fine, we can do it manually, I know they haven't integrated it into their strategy. True success is when AI becomes a natural extension of human thought, neither replacing nor separating from it. Another aspect that few people notice is how AI changes organizational structure. It forces departments to collaborate. This is because one side's data is often the answer to another's problem. But cultural barriers lead many places to fail. Technical teams speak the language of models and algorithms, while leadership speaks the language of strategy and people. A bridge is needed between these two worlds, individuals who understand both sides, who grasp both data and business. I call them the unicorns of the AI age. Unicorns are not just symbols of rarity, but a reminder that the combination of intelligence, technical skill, and business acumen is almost irreplicable. I once met a data engineer who could speak to the executive board in the language of profit and simultaneously communicate with the programming team in the language of models. He didn't talk about neural networks. He talked about how each percentage point of accuracy saved X dollars. It's that kind of thinking that transforms AI from a tool into an asset. Not everyone can become a unicorn, but every organization needs at least one to survive. However, the frightening thing is that many places think simply hiring the right person is enough. They forget that a unicorn cannot thrive in a forest full of barriers if the corporate culture doesn't allow data sharing. If departments still compete instead of collaborating, then no matter how many talented experts there are, AI will remain a lonely machine. Without a suitable environment, talent will erode, and technology will become mere decoration. I once witnessed a company create a luxurious data room with giant screens displaying constantly moving graphs. Whenever visitors came, they would stop there to take photos, as if watching a space control center. But no one in the company knew exactly what those numbers meant or who was using them to make decisions. They had turned AI into a performance stage, not an operational tool. And that is what troubles me most. Humans always seek magic, but true magic lies in discipline. AI doesn't need to be worshipped. It needs to be understood and used correctly. The most successful projects I've seen were not flashy. They were built by humble, patient individuals who always asked, "How does this result help us act differently?" They didn't talk much about algorithms. They talked about the real impact on people and society. When the final meeting of a successful project ended, no one mentioned AI anymore. They talked about customers being better served, about processes becoming faster, about decisions being made more accurately. That's when AI disappears from the spotlight, leaving room for something more important, the real change in how humans operate the world. And perhaps that is the ultimate goal of the implementation era, not to make technology greater, but to make humans wiser. When we understand that AI is just a tool to illuminate what we already knew but didn't dare to confront, when we dare to question all old habits and beliefs, then technology truly fulfills its mission. AI is not the world changer. Humans are, if they are sober enough to learn from the mirror they created. Once, during a conversation with the leadership team of a long-established industrial conglomerate, I asked them, "Do you know why most AI projects fail?" One person replied, "Because of dirty data," another said, "Due to a lack of talent." I smiled and said, "No." I told them the reason lies in the fact that they think AI is a technology project, when in reality, it's an organizational change project. The room fell silent, and in that moment, I saw looks of confusion mixed with defensiveness. People are often more afraid of changing themselves than of machine failure. I've learned that when AI enters the boardroom, it doesn't just bring data, it brings a mirror. In that mirror, each leader sees the inconsistency between what they say and what they actually do. They talk about innovation but still reward and punish based on old processes. They talk about data but make decisions based on emotion. AI doesn't reveal system flaws, it merely magnifies existing weaknesses. Many assume applying AI is a technical journey, but it's actually a journey of perception. Each technological advancement forces humans to re-examine how they think, how they make decisions. Technology is never absolutely objective. It reflects the values, priorities, and biases of those who design it. When we ask AI a wrong question, we're teaching it to misunderstand the world, and then we blame it for reflecting precisely what we instilled. In a successful business I collaborated with, they started by asking very small questions. If this model is correct, what will we do differently? A seemingly simple question, but it's the foundation for every effective AI strategy. They didn't build large systems immediately. They chose a specific, measurable problem and focused on solving it from beginning to end. Their success came not from expensive technology, but from the discipline of asking questions. Conversely, in many other places, I see a frightening display of ostentation. They talk about digital transformation, about smart systems. But no one has time to talk to customers, no one asks employees what they need. They let AI do human work, while humans chase after machines. Technology, if not placed correctly, will turn users into its servants. Another time, I was invited to a bank implementing an automated credit scoring system. They proudly stated that the model could predict default probability with 96% accuracy. I asked, "And do you know who the remaining 4% are?" No one answered. I continued, If, among that 4%, there's a loyal customer denied because the system doesn't understand their circumstances, would you dare to take responsibility? The entire meeting room fell silent. When AI makes decisions instead of humans, responsibility doesn't disappear, it merely changes form. It's dangerous to believe that a model can be absolutely fair. Data reflects the past, and the past always contains injustice. If we don't correct the data, AI will relearn those errors 1,000 times faster. An algorithm doesn't discriminate, but if the data it learns from has been discriminatory, the results will remain the same. AI doesn't know what justice is, it only calculates. It's humanity's responsibility to teach it the limits of mathematics and the boundaries of ethics. I always believe that technology truly matures when it helps humans become more profound, not more dependent. Some teams have used AI to automate personnel selection, saving time, but they don't let AI replace their human judgment. They use it as a tool to filter information, then dedicate time to meet and listen. The result is they hire more suitable, more loyal individuals. AI doesn't do our work for us, it helps us do it better. In a manufacturing plant, a predictive maintenance system was put into use. Initially, workers worried they would be replaced, but the wise manager said, "No one is losing their job. We are just learning to listen to the machine before it cries for help." They began to converse with the data as if with a living entity. Performance increased, accidents decreased, and people felt they were masters of the technology, not controlled by it. That was a rare harmony between artificial intelligence and human intelligence. When I look back at all those stories, I see one thing clearly. AI is not a destination, but a mirror reflecting the evolutionary journey of human thought. It forces us to question what seems obvious, to confront our own limitations. Every line of code is not just a command for a machine, but also a mirror reflecting the values of the person who wrote it. And if humans aren't humble enough to look into that mirror, all technology becomes meaningless. That's why I believe success with AI doesn't come from organizations with the largest capital, but from those with the deepest patience. Patience to understand, to learn, to adjust, to admit mistakes. They're not afraid to ask questions, not afraid to stop when they realize they're going in the wrong direction. They understand that every wrong result isn't a failure, but a reminder of the complexity of the real world. And above all, they understand that AI wasn't born to replace intelligence, but to reflect it. When humans are brave enough to look into that mirror without fear, humble enough to learn from their own mistakes, that's when technology truly becomes meaningful. AI doesn't save the world, it merely gives us the opportunity to see ourselves more clearly. The true success of an AI journey doesn't begin with the algorithm, but with how people choose where to plant the first seed. Many organizations have failed not because they lacked experts, but because they chose the wrong field. They were enchanted by promises of artificial intelligence, poured millions of dollars into colossal projects, and then found they had no idea what to do with the results. The question that should have been asked from the start wasn't, what can we do with AI? But how can we act differently if we have AI? Choosing the right inaugural project is the seed that determines the entire harvest that follows. No one builds a civilization with just an experimental model. But if the first project heads in the wrong direction, the entire organizational culture will follow suit. Those who have failed in large projects often carry a scar. They no longer believe in data, in analytics, or in their own ability to change. So, when starting, what's most needed isn't boldness, but wisdom. In every AI journey, there's a land called quick hunting grounds, places where early, tangible results are easily seen. These are processes with existing data, clear business metrics, and individuals responsible for making real decisions. If the first project can help them make decisions faster and more accurately, the organization will gain the confidence to continue. Trust is the initial fuel for success, not budget or technology. When a team prepares to launch its first AI project, they need to ask themselves whether the research question they're posing is truly linked to a business problem. If the question is merely technical, the project will end up beautiful but useless. A model might achieve 99% accuracy, but if it doesn't lead to any action, its value is still zero. Therefore, every project must begin by identifying a business action that can be taken immediately upon receiving results. That's why the CLUE framework was born. The 4 simple letters of CLUE are the axis around which all AI thinking revolves. First, consider the real business action that can be taken. Then, link the research question to that action to ensure that analytical results can be translated into decisions. Next, understand the meaning of the results in a real-world context, not in a laboratory. Finally, conserve resources, because everything in the world of AI is expensive, from data and personnel to time. Without clue, every project can become a trap. The first trap is copying success from elsewhere. A model that helps an e-commerce company increase revenue doesn't mean it will save an insurance company. The second trap is the moonshot project, colossal ambitions without a rocket. The third trap is tool fetishism, thinking that merely buying good software is enough. The fourth trap is placing faith in intuition instead of data, turning AI into a screen for improvisation. And the final trap is separating the technical team from the business team, leaving programmers unaware of the goals and decision-makers ignorant of the data. A sound project doesn't need to be grand. It needs to be compact, measurable, with real users and real feedback. I once witnessed a company choose its first project simply to predict maintenance needs for its machinery system. They didn't talk about Industry 4 revolutions or declare they were changing the world. Yet, after just 3 months, they saved hundreds of thousands of dollars and significantly reduced production line downtime. That small success became the first brick in building their confidence in their data capabilities. Another important principle is, if you must fail, fail fast. Every day that passes without real feedback is a wasted day. An AI project must be designed as a continuous learning system. Build, measure, learn, revise. If a model isn't working, stop early, adjust direction, or choose a different problem. No one needs a project that drags on for 3 years just to prove it's ineffective. AI's success lies not in getting it right the first time, but in the ability to learn faster than competitors. But to learn fast, you need the right metrics. You can't call a project successful if you don't know what success looks like. A technical metric like accuracy or error rate is only meaningful when it leads to a specific business metric, for example, how much revenue increased, how much cost decreased, or whether customer retention improved. Every organization that wants to grow with AI must learn to measure value in the language of business, not just in technical numbers. And above all, the most important thing is people. AI doesn't change the world by itself. Humans do, when they dare to change their way of thinking. I've seen many talented engineering teams fail because they lacked someone who understood people, and I've also seen many small businesses succeed because they had a leader who knew how to ask the right questions. The right question is the spark that ignites every intellectual process. Finally, when the first project concludes, what remains isn't just data or models, but a change in culture, how people talk about problems, how they make decisions, how they perceive true value. From there, AI is no longer a project, but a way of thinking. An organization that knows how to choose the right first project has chosen a path of sustainable evolution for itself, and that is the true beginning of every journey into artificial intelligence. The link between technical and business aspects is always a fragile boundary where many organizations stumble. Not because they lack data, nor because they lack skilled engineers, but because they speak two different languages. Engineers view the world through numbers, accuracy, error rates, charts, and loss functions. Leaders, meanwhile, view the world through cash flow, customers, and profit. When these two worlds don't intersect, every technical achievement becomes an echo in a void. I once sat in a meeting where the technical team gleefully presented that their prediction model had achieved 98% accuracy. They spoke with the pride of having reached a scientific pinnacle. But the CFO asked one single question: "So, how much more money does that help us make?" The entire room fell silent. That question was as simple as it was brutal, exposing the gap between technology and business, a gap that AI cannot bridge on its own if humans don't build a connection between the two banks. That bridge is the L in the clue framework. It's not just a logical connection between model and objective, but a unification of meaning. A risk prediction model doesn't exist to prove its accuracy, but to help humans act sooner, mitigating real losses. A customer segmentation model has no value if the marketing department cannot use it to adjust campaigns. Linking technical and business means transforming technical progress into actionable steps that can be measured in the language of real-world impact. To do this, an intermediate concept is needed: the profit curve, fit curve. It's how humans translate model improvements into economic value. When the model improves by a few percentage points of accuracy, what happens to profit? This impact isn't linear nor simple. Sometimes, even a very small improvement brings colossal benefits. But sometimes, doubling accuracy doesn't create a significant change. The profit curve helps us see the true relationship between technical and economic aspects, helping us know when to continue and when to stop. I once witnessed an insurance company that understood this. They didn't let the technical team chase infinite accuracy. They set clear limits. If the model helped reduce the claims ratio by 3%, they had achieved their business goal. Beyond that point, each additional percentage point of improvement cost too much for negligible benefit. Understanding the limits of value is an expression of practical wisdom. Better isn't always more valuable. The difference between technical metrics and business metrics is like the difference between a heartbeat and life itself. A body with a perfect heartbeat can still die if blood doesn't circulate correctly. Similarly, a model can meet all statistical criteria without delivering real impact. Technical metrics tell us how well the model works, but business metrics tell us whether the organization is truly healthy. Many organizations fail not because their models are wrong, but because they don't know how to tell the value story of their model when there's no way to measure the benefit. No one knows what to believe. The engineers say the model is good. The leaders say they haven't seen results. Eventually, trust erodes. To avoid this, a common language is needed between the two worlds, where every technical improvement is translated into tangible impact. How much time saved, how much cost reduced, how many customers retained. In a retail project, the technical team once spent months refining a product recommendation model. When they presented the results to the business team, no one cared. But when they represented it as a story, that if this model worked correctly, the repurchase rate could increase by 10%, and annual revenue could rise by millions of dollars, the atmosphere changed. Leaders don't see source code, they see numbers and action. The common language isn't in the algorithm, but in the ability to tell the data's story in human language. This requires both sides to relearn how to listen to each other. The technical team must learn to talk about value, not just models. The business team must learn about the principles of machine learning to understand its limits and capabilities. Both sit down together, define goals together, and define what success looks like together. When they understand that no one is right alone, they truly begin to collaborate. Without such collaboration, AI is just a machine standing still between two worlds that don't understand each other. I always remind teams that if a model is good but the organization cannot change its behavior, then the project is still a failure. Success only comes when data leads to action, and action leads to real results. This demands humility. Engineers must accept that numbers are not the end, and leaders must admit that their intuition isn't always right. Between intuition and data, value is only generated when both engage in dialogue. Some organizations have completely transformed once they understood this. They no longer see AI as a separate department, but as a bloodstream flowing through all operations. Technical and business teams sit side by side, sharing the same dashboards, the same feedback schedules. Whenever a model improves, they don't say accuracy increased, they say customers are more satisfied. That's when AI becomes the common language of the organization, a language that doesn't divide people, but unites them around true value. When those two worlds meet, magic happens without the need for grand slogans, just a small change. Engineers begin to think with a business mindset, and leaders begin to ask questions with a data mindset. Every step forward in the model becomes a step forward for the business. And at that moment, the language of numbers merges with the language of humans to tell a single story. The story of how understanding leads to action, and action leads to true value. Every AI system has a soul, and that is the machine learning pipeline. It's not just a piece of code, nor a few isolated models running, it's the living chain of the entire process. Data flows in, is processed, learned from, predicted upon, and then feeds back into itself through feedback. If we liken an organization to a body, the pipeline is the circulatory system, and data is the blood flowing through it. If that flow is blocked, even at a single point, the entire system will cease to function. Unlike traditional software, where results are absolutely determined, AI is a constantly evolving entity. It must not only run correctly but also learn correctly, and that learning never stops. Human resources management software can operate stably for years, but an AI system used to predict labor productivity can become inaccurate after just a few months if the input data changes. Flexibility is not an option, it's a condition for survival. In a project I was once involved in, the technical team spent over half a year fine-tuning a model achieving superior accuracy. But when it was actually deployed, the results rapidly plummeted. They couldn't understand why until they discovered that the data pipeline had changed. A small information column was recorded in a new format, causing the model to misinterpret everything. The problem wasn't with the algorithm, but with the system that fed it. A good model can die prematurely simply because of a bad pipeline. The three pillars of every AI system are data, methods, and infrastructure. Data is the raw material, methods are the intelligence, and infrastructure is the physical body for everything to operate. If the data isn't reliable enough, the model will learn incorrectly. If the methods are unsuitable, the model will learn slowly. If the infrastructure is unstable, the model will never be used. Many organizations focus only on one pillar, usually the algorithm, and neglect the other two. They think adding computational power will solve everything, but AI's performance depends on the balance between these three factors. An imbalance in one pillar will cause the entire system to collapse. When I talk about the machine learning pipeline, many people visualize it like an assembly line. Data goes in, results come out. But the reality is more complex. Each node in the pipeline is a decision about how to sample, how to handle bias, how to evaluate, how to update. Every temporary decision can become a permanent fossil if not reevaluated. I call this phenomenon fossilized pipelines, when a flexible system gradually becomes frozen by its own past human choices. One company encountered this situation. They started with a temporary data processing procedure, thinking they would fix it once the project was stable. But 5 years passed, and that procedure remained unchanged, becoming the backbone of the entire system. Every time they wanted to improve, they had to painstakingly avoid touching those legacy parts for fear of breaking the whole chain. They no longer owned an intelligent system, but merely a tired machine held together with duct tape. Flexibility disappears when humans stop learning from their own pipelines. The paradox is, the more organizations adopt AI, the fewer truly understand how their pipeline operates. They can describe the model, but they can't map the journey data takes through how many layers of filtering, how many transformations, and who is responsible at each stage. Without responsibility, there is no evolution. A machine learning pipeline cannot self-regulate quality. It needs human oversight, just as a farmer must check the water source. Data engineers must regularly review the data flow to ensure that what the system is eating remains clean and correct. A good pipeline not only runs smoothly, but also has the ability to self-feedback. This means that whenever results change abnormally, the system signals for humans to investigate the cause. This might seem simple, but it's the difference between an intelligent organization and a blind one. An intelligent organization doesn't blindly trust AI. They let AI challenge them. When the model produces unusual results, they don't panic but become curious. What has changed in the outside world that caused the system to react this way? They don't just fix the model, they learn from its discrepancies. In this process, maintaining a holistic view is crucial. Many teams get too engrossed in technical details and lose sight of the big picture. They fix small segments of the pipeline, but don't realize that each adjustment creates a ripple effect elsewhere. A mature organization is one that knows how to coordinate the rhythm between localized improvements and overall stability, much like a conductor leading an orchestra. They don't let any instrument overpower, nor any sound fall out of sync. There's one thing I always emphasize: AI is not a one-time project. It's a living entity that must be continuously nurtured. Every new stream of data is a meal. Every market change is a survival challenge. A good pipeline isn't sealed off. It breathes, it adapts. And for it to do that, humans must have the mindset of a caretaker, not an owner. AI doesn't need to be controlled. It needs to be guided. When an organization understands that the pipeline is its heart, it starts to behave differently. They don't just care about the final results, but meticulously tend to each intermediate stage. They know that value doesn't lie in how many times the model predicted correctly, but in whether the entire operational chain is reliable. That's when AI truly becomes part of the knowledge ecosystem, no longer a tool but a living partner, reflecting the maturity of the entire organization. A pipeline that knows how to learn is the true soul of every successful project. The true success of an AI system doesn't lie in the model, but in the operational capability of the entire chain. Any technology, no matter how sophisticated, will become useless without a structure to maintain a steady operational rhythm. Many organizations fail not because they don't understand AI, but because they don't understand themselves. They lack the processes to nurture a system that is constantly learning, constantly providing feedback, constantly evolving. That's why I believe that after choosing the right direction and building a machine learning pipeline, the most important thing is to create a seamless deployment rhythm between people, technology, and action. That rhythm begins with a very small point. A practical question: what in our operations needs better decision-making? That question leads to the first action: defining the data to be collected, the metrics to be checked, and the visible success criteria. As that cycle repeats, it becomes a living loop. Question, analyze, act, learn, ask new questions. AI only truly becomes meaningful when it becomes a natural part of that cycle. An intelligent organization doesn't view AI as a standalone department, but as a network permeating every layer. Each department has a role in the pipeline: data collectors at the source, decision makers at the end of the chain, and engineers and analysts in between. If one link doesn't understand what it's serving, the entire chain will go astray. This is why humans stand at both the beginning and end of every AI cycle. They both ask questions and bear responsibility for acting on the answers. I've seen many businesses fall into a strange situation. Models run stably, data is plentiful, but the impact is vague. The simple reason is that no one is willing to make decisions based on the results. They let the system run, reports fill up, charts glow brightly, but all actions are still based on old habits. AI cannot change an organization if humans don't change their decision-making habits. Each model is merely a suggestion, not a command. The real power lies in humanity's response to those suggestions. In a manufacturing project, the technical team built a highly accurate system for predicting machine breakdowns. But for the first 6 months, no one in the factory used the results to plan maintenance. The reason wasn't in the technology, but in the process. They lacked a feedback channel between the model and the equipment managers. When that bridge was established, efficiency increased in the very first month. An AI system without human action accompanying it is just a beautiful clock without hands. The greater the scale, the greater the risk of disconnection. Each team optimizes its own part, but no one looks at the whole. Data analysts want to increase accuracy, operations teams want to save time, leadership wants to reduce costs. But if there's no common voice, each person will pull the system in their own direction. The real challenge isn't to make AI smarter, but to make the organization more unified. That unity comes from discipline. Every AI project needs a clear rhythm. Start small, test under control, learn fast, scale structurally. When a cycle ends, the team must sit down and review what worked, what didn't, and why. No one should be allowed to view incorrect results as failure. Instead, they must be seen as data for learning. Without learning, there is no evolution. Without evolution, AI will become a technological zombie, operating but without vitality. I often say that every organization should have an AI mirror day, a day when they don't look at the results, but at how they themselves created those results. They review processes, data, feedback, and decision-making. If everything is exactly the same as day one, that's a sign of stagnation. A machine learning system that humans don't learn alongside is a dead system. Like all living organisms, an AI system needs to be regulated. You can't let one group of engineers define the entire direction, nor can you let leadership impose decisions without understanding the data. Both must share power. Engineers speak the language of models, leaders speak the language of value, and both meet in the language of learning. When that happens, organizations no longer fear data. They view data as an ally. The maturity of an organization is measured by how many times it dares to correct itself through data. What makes me believe is that no matter how complex the world of AI, it still adheres to the simplest law. What survives is what learns fastest. And learning fast doesn't mean running fast. It means timely feedback, changing in the right places, and understanding limits. An organization that knows when to stop when a model is wrong is more trustworthy than one that constantly insists it is right. Humility is the core software of all success in the AI era. When humans understand that AI is not just a tool but a mirror reflecting how they operate, they will nurture it like a living being. They won't demand perfection but let it grow with them. And then the entire organization enters a new phase, no longer talking about AI projects, but about an AI culture, where every decision, no matter how small, is based on learning and feedback. A mature organization is one that looks at today's results and asks, what will we learn from this tomorrow? I realize that the most sustainable thing isn't which model runs faster, but the spirit of learning that permeates every individual when they aren't afraid to try, aren't afraid to fail, and aren't afraid to change. AI will no longer be an alien technology. It will become a natural part of collective intelligence. And in that moment, humans will no longer chase machines. They and machines will learn to evolve together, writing the continuing story of understanding and action. Every AI system, no matter how sophisticated, is a body with its own rhythm. It inhales data, transforms it into understanding, and then exhales decisions. But this body truly lives only when its internal pathways are clear. If there's a bottleneck, however small, the entire system will become imbalanced. Where a machine learning pipeline is weak, the entire organization holds its breath there. Therefore, the project leader's first task isn't to choose a more complex model, but to dissect the existing pipeline to find which stage is limiting value. Within the CLUE framework, this is the resource conservation step, not just saving costs, but ensuring that every step in the chain serves the ultimate goal, real business value. To see the limits, we need a tool that is both objective and simple enough not to be distracted by technicalities. Min-max analysis is a straightforward idea. Each component in the pipeline can be viewed as an input variable, and the system's final result is the output. We change the value of each variable within acceptable limits and observe its effect on the outcome. If a small change in one stage causes the entire result to fluctuate wildly, that's a bottleneck. If a large change yields almost no difference in the result, that stage is over-engineered. Min-max helps pinpoint which link is holding back the potential of the entire system. For example, if changing the classification algorithm only improves the result by 1%, but cleaning the input data increases accuracy by 15%, we know where to invest our time. In a business environment where resources are always limited, understanding this is crucial for survival. A common mistake is to assume that simply adding more data and increasing model power will lead to better results. But min-max analysis shows the opposite. Sometimes, adding data makes the system noisier, slower to learn, and worse in its results. Every pipeline has a saturation point. Beyond that limit, effort doesn't yield proportional benefit. Knowing when to stop is a form of maturity. To apply min-max effectively, we need to clearly define the metrics for results in the AI domain. This is often confused between technical and business metrics. A model can achieve high accuracy, but if it doesn't improve actual decisions within the business, it's just a phantom victory. Min-max must be measured against business metrics, not internal numbers. A classic example is a product demand forecasting project in a retail chain. The engineers eagerly optimized the forecasting model, but when checked with min-max, they found the real limitation was in inventory updates. Data was imported too slowly, making all predictions, however accurate, useless by the time they reached management. When the data delay was changed from 48 hours to 12 hours, profit doubled without needing to change the model. That's the power of correctly understanding limitations. Min-max analysis also forces us to confront an uncomfortable reality. Many systems are built in a tangled, unstructured way, making even a small change in one stage cause chaos throughout. To resolve this, we need to view the pipeline as a continuous flow, not a series of isolated modules. Every change has a ripple effect, and min-max is the map that helps us visualize how that wave spreads. After identifying the min and max points, managers must choose where to invest first. This is not just a technical problem, but also the art of balancing cost and risk. The stage with the biggest impact isn't always the one that should be fixed first, especially if it's deep within the infrastructure. Changing it could trigger a cascade of consequences. The principle is to choose the bottleneck closest to the business outcome, where a small, safe change creates a large effect. What's interesting is that, when executed correctly, min-max analysis not only optimizes the pipeline, but also changes the team's mindset. They begin to understand that instead of debating which model is better, they should ask which stage is hindering true value. This process fosters a culture of continuous learning, where data is seen as a tool to understand oneself, not to prove oneself right. Many organizations, upon hearing about min-max, assume it's a dry concept, but it actually carries the essence of Eastern thought, understanding extremes to maintain balance. If you know the highest and lowest limits of a system, you'll know where the safe zone lies. That's not resignation, but awakening, knowing when to push and when to stop. Dissecting the machine learning pipeline isn't about finding errors, but about understanding the structure of life within the system. Every data stream, every calculation, every decision is a small heartbeat of the entire body. Min-max is simply a stethoscope that helps us listen to that heartbeat more clearly. When done well, we not only have a functioning model, but an organization that breathes, responds, and learns. That is the true healthy state of an AI system. When we begin to dissect an AI pipeline, what's essential isn't how powerful the tools are, but how we look at the system itself. Min-max analysis isn't about showcasing computational prowess. It's about seeing the true limits of each link, limits concerning data, processes, and people. It's from seeing these limits that we can intelligently restructure, rather than blindly tearing things down. To properly implement min-max, the first step is to build a simulated model of the pipeline where each stage can be independently altered. This requires a deep understanding of the data flow, where it originates, where it's transformed, and where it ultimately goes. Not a few organizations, when attempting this method, realize they don't actually know the structure of their own pipeline. Data flows through dozens of intermediate tools, with different people touching it at each point. When no one is fully responsible, no one truly learns anything. Once the flow map is established, we begin to vary the parameters, not to test our luck, but to understand the system's dynamics. We increase data filtering intensity, reduce the number of training variables, change update frequencies, and then record the impact on the output. This is akin to medical testing, changing the dosage of each component to see how the body reacts. A machine learning system is also a living organism, and min-max is the art of listening to its reactions. After each round of testing, we have a sensitivity map, which stages have the strongest impact, which are almost meaningless. Here, an uncomfortable truth emerges. Much effort in AI projects creates no value at all. Engineers might spend weeks fine-tuning a model, while the real error lies in the data entry process. In some cases, simply changing the storage format can double the overall results. That's not a technical failure, but a humble lesson in system complexity. When min-max results point out weak links, organizations often tend to patch them immediately. But if you only fix the weakness without understanding why it was weak, the error will recur elsewhere later. Optimization is not an action, but a process of deep understanding. Therefore, each time a limit is discovered, we need to trace its origin. Is it due to structure, data, or people? If the error lies in the process, change the way of working. If in the data, improve data collection. If in mindset, retrain how value is perceived. Also during this phase, we begin to see the fossilized pipeline phenomenon, where a temporary decision from some past moment has solidified into an unchangeable standard. It's like a calcified artery. It still carries blood but has lost its elasticity. For example, one company once set a rule to filter out all records with null values, and that rule persisted for years. But when data changed, that very rule caused the loss of numerous important signals. A fossilized pipeline is a sign that an organization has stopped learning. To break the ice, we need to start by asking, why was this rule created, and does that circumstance still exist? Only when humans dare to question even what they once considered truth can the system come back to life. The process of regeneration doesn't mean starting from scratch, but making the system capable of self-adjustment. A good pipeline isn't one that never fails, but one that can recover after each deviation. Distinguishing between model errors and system errors is a critical step in this phase. A model error is when the algorithm learns incorrectly. A system error is when the environment causes the algorithm to no longer be correct. If we only look at technical metrics, it's easy to confuse these two. But min-max forces us to look at the whole picture. If a small environmental change causes results to fluctuate wildly, it indicates the system is overly dependent on a fragile assumption. And in that case, it's not the model that needs fixing, but the operating procedure. There's a paradox. Many teams think that doing AI is about automating decisions, but too much trust in automation causes them to lose their critical thinking ability. Min-max reminds them that true intelligence lies in asking questions, not in having many answers. When we analyze the limits of the system, we are also analyzing our own limits. Restructuring the pipeline after obtaining min-max results is not easy. Every technical change brings cultural change. Managers must know how to create space for experimentation, accepting short-term failures in exchange for long-term understanding. If an organization only rewards results, no one will dare to explore limits. But if the learning process is rewarded, everyone will see min-max as an opportunity for discovery, not a test. The ultimate goal of min-max analysis is not to perfect the model, but to keep the system capable of evolution. A system that understands its limits is a system that can grow sustainably. When we know the extremes, we no longer fear making mistakes, because we understand the extent of our errors and our correctness. And when fear disappears, creativity returns. The machine learning pipeline, after being dissected and regenerated, is no longer a cold array of tools. It becomes a living entity that responds, learns, and self-adjusts to the world's changing rhythm. Humans no longer have to control it. They just need to listen, guide, and let it learn with them. That is the moment when AI is no longer technology, but becomes knowledge about how we ourselves understand and operate life. After thoroughly understanding the pipeline structure and determining its limits with min-max, the next step is to identify what in the system most strongly influences the results and how that influence changes over time. Here, we delve into the deeper realm of AI governance, sensitivity analysis, and time rhythm management. If min-max helps us see the extremes, sensitivity tells us whether the path through those points is steep or flat. And the time rhythm indicates where we should stop and when we should continue. Sensitivity analysis is divided into two types, local and global. Local sensitivity is when we change one small factor to see the immediate reaction of the results. Global sensitivity is when we change multiple factors simultaneously to understand their interactions. In a complex AI system, this is extremely important because no factor operates in isolation. Data, algorithms, hardware, training frequency, all are interconnected links influencing each other. Understanding sensitivity means understanding the dynamic nature of the system. For example, in a demand forecasting project, engineers found that increasing the model update frequency from weekly to daily significantly improved results. But when they tried increasing it to hourly, results declined. Sensitivity analysis revealed the cause. The data was too noisy within short timeframes, causing the model to churn endlessly due to continuous changes. Sensitivity helped them see that faster isn't always better. It needs to be the right rhythm. At the global level, sensitivity allows us to see cross-relationships. A change in data cleaning methods could make a classification algorithm behave differently, or expanding the forecasting scope could increase processing latency. When we look at the whole picture, we realize that every technical decision is a chain reaction where improvement in one area can weaken another. This makes AI management akin to playing an instrument, not just increasing the volume of each instrument, but harmonizing the entire orchestra. Sensitivity also helps identify profit levers, where a small change yields a large economic impact. For instance, a predictive maintenance model can save millions of dollars by reducing the failure rate by just 1%, whereas an internal email classification model, even with perfect accuracy, might not yield significant value. Sensitivity analysis is the compass that guides investment, indicating where effort is worthwhile and where it should remain at the experimental stage. Parallel to sensitivity is the time factor. In reality, the value of an AI project is not fixed. It fluctuates with the business's operational rhythm. A model that is correct this month might be meaningless next month as markets change, user behavior shifts, or supply chains restructure. All of this means models need continuous adjustment. Therefore, we need a tool to visualize value along the time axis, the time value point graph. On this graph, the horizontal axis represents time, and the vertical axis represents the business value the model delivers. Initially, the curve rises quickly as the model improves. Then it gradually flattens as it reaches a saturation point. Finally, it declines as the model becomes obsolete. Understanding the shape of this curve is the only way to know when to continue investing and when to stop. If we stop too early, we miss potential. If we prolong it, we waste resources. This leads to an important principle. The value of AI lies not in the training speed, but in the organization's learning speed. An organization that understands and reacts promptly to external fluctuations will sustain value longer. Conversely, an organization that only knows how to improve its model without changing its processes will fall behind, no matter how good its model. The time rhythm in AI, therefore, isn't just about update frequency, but about the feedback rhythm between the model and humans. In many projects, determining the endpoint is a difficult decision. When do you know a project has succeeded? The answer isn't when the model achieves its highest metrics, but when the business value reaches a stable level and can be sustained without continuous intervention. This requires the organization to be able to measure real impact: money saved, increased efficiency, or reduced risk. Measuring true value is how a project truly concludes. And when the project ends, the real work begins, learning from the entire process. What we discover in sensitivity and time rhythm analysis isn't just useful for one system, but for all subsequent projects. It helps establish a principle. Each AI deployment is a new learning cycle for the organization. Success must be a result, but also the ability to reuse the knowledge gained. Looking back at the entire journey, we will see three intertwined elements. Min-max teaches us to understand limits, sensitivity teaches us to understand impact, and time teaches us to understand the life rhythm of value. Together, they form a balanced triangle of performance, cost, and timing, the foundation that any organization wanting to live with AI must master. Neglecting one of these three factors will cause the system to deviate. Mastering all three allows the organization to operate like a self-balancing organism. And it is in this balance that AI is no longer an experimental project, but becomes a core capability of the organization, a capability not just to predict the future, but to live fully in the present. Once an organization has completed the journey from choosing the right problem, linking business with technology, building a stable pipeline, and analyzing sensitivity and time rhythm, the remaining question isn't, how do we deploy AI? But where will AI take us? At this stage, the goal is no longer short-term efficiency, but a long-term vision. Understanding the trends that will shape the future of artificial intelligence and its impact on humanity itself. The first thing to accept is that the definition of AI isn't fixed, it's redefined every decade. Once, AI meant simulating human thought, then it became machine learning, deep learning, and now, the automation of entire decision-making processes. AI is not just technology, but a shift in how we understand knowledge. This demands that humans constantly relearn what they thought they already knew. One clear trend is the integration of AI into physical systems, from factories to autonomous vehicles, from medical devices to smart grids. In this world, AI errors are no longer just data discrepancies, but can lead to real physical consequences. Therefore, a classical principle of medicine suddenly becomes highly relevant. First, do no harm. When AI controls machinery, systems must be designed so that errors do not lead to disaster. The engineer's first duty is no longer creation but protection. Alongside this is the issue of security and privacy. As every device connects, personal data becomes the primary raw material for artificial intelligence. The question is no longer, how much can we collect? But how much should we collect? Ethical boundaries cannot be left to machine learning. They must be defined and maintained by humans. Otherwise, the smarter the system, the deeper the harm. Power without ethical limits will no longer be progress but risk disguised by speed. It's crucial to remember that AI, no matter how accurately it can predict, doesn't understand causality. It sees patterns, not reasons. This makes it powerful in prediction but weak in explanation. A model can say who will leave the company, but not why they left. Therefore, humanity's role remains that of the storyteller, the interpreter, the bringer of meaning. When humans hand over all interpretation to machines, the world will be full of predictions but lacking understanding. Another boundary is also increasingly blurred: machine errors and human errors. When AI suggests a wrong action, who is responsible? The coder, the decision maker, or the system itself? Many businesses face this question daily. The solution isn't in finding a culprit, but in designing clear accountability processes. AI has no ethics but can be operated within an ethical framework. It is this framework that determines whether the system serves humans or controls them. And then, a new turning point emerges: AutoML, the automation of model building. Previously, dozens of experts were needed to fine-tune parameters. Now, just a few automated commands suffice. This ushers in an era where any organization can possess AI without deep expertise. But simultaneously, it raises a bigger question. Once building is automated, what will be humanity's role? The answer lies in a shift from builder to guide. In the future, the greatest value will no longer be in writing code, but in defining problems, setting ethical criteria, designing feedback loops, and ensuring the system learns what it needs to learn. Knowledge guardians will replace the position of the pure programmer. They don't control machines, they nurture collective intelligence between humans and AI. An inevitable consequence is that the boundary between human knowledge and machine knowledge is dissolving. AI learns from human actions, while humans make decisions based on AI's feedback. If not guided carefully, this process can easily become a self-amplifying loop of errors. But if designed wisely, it becomes an evolutionary cycle where humans and machines learn, adjust, and grow together. Some worry that AI will replace human intelligence, but in reality, it only magnifies human nature. If we are blind, the machine will multiply that blindness. If we are wise, the machine will multiply that wisdom. AI doesn't create ethics, it reflects existing ethics. So, instead of asking how to make machines ethical, perhaps we should ask how to make humans more ethical when machines are present. Here, we return to the initial spirit. All that is learned from building, analyzing, and operating AI not only helps us understand machines better, but also helps us understand how organizations and ourselves operate. An intelligent system isn't intelligent because it can learn, but because it forces us to learn along with it. When we understand this, we no longer see AI as a machine, but as a mirror reflecting humanity's evolutionary capacity. And then, in that reflection, we realize technology is never the destination. It is merely a means for us to explore new limits of perception. We are not just witnessing the AI revolution, we are creating it every day by how we choose to learn and understand. Success with AI is not a story of technology, but a journey of humanity learning to dialogue with its own knowledge. This book, at its deepest core, doesn't teach us how to program, but how to understand limits and overcome them with awareness. It begins with seemingly technical questions: which project to choose, how to measure, but it ends with an almost philosophical contemplation. AI is not an intelligent machine, but a mirror reflecting the intelligence of its creator. The greatest lesson here isn't in the models or algorithms, but in how organizations learn from their own mistakes. The author doesn't talk about victory, but about the endurance of intelligence, the ability to recognize that failure isn't an end but raw material for faster learning. When an AI system operates, it only does what humans teach it to do. Therefore, if we want a system that knows how to learn, we ourselves must be the first to learn. We live in an era where data can measure everything except understanding. We can predict the behavior of others, but don't know what makes us act ourselves. AI opens an opportunity to reflect, not to look out at the world, but to look inward at our cognitive structure. If data is a map of the world, then AI is a mirror reflecting how we read that map. Therefore, the ultimate question isn't, how can AI succeed in your business? But are you willing to change your understanding of success? In many cases, AI's success isn't about helping us know more, but about helping us know when to be silent, stop assuming, stop judging, to observe what the data wants to say. Perhaps in the noisy world of algorithms, the ability to be silent and listen is the rarest form of intelligence. Perhaps you are in an organization just beginning its AI journey, or simply an individual curious about the future. Wherever you are, start by asking, what problem do I truly want to solve? Without the right question, every model is meaningless, and with a sufficiently right question, sometimes you don't even need AI to find the answer. Artificial intelligence is only powerful when nurtured by human intelligence. Imagine that in a few years, AI will no longer be an external tool, but become the underlying layer of every activity, from work, medicine, and art to the smallest decisions. At that point, what defines value won't be who has more powerful technology, but who understands their own nature more deeply. Because machines can copy actions but cannot replace meaning. Have you ever wondered, if AI can simulate human voice, facial expressions, and even thought, what remains that makes us different? Perhaps it is the ability to accept contradiction, to live with paradox, and not to need absolute answers. AI aims for accuracy, humans aim for understanding. And perhaps between accuracy and understanding, we still choose understanding, because understanding makes us human, while accuracy merely makes us efficient. The journey of AI, ultimately, is a metaphor for the evolutionary journey of consciousness. Each time a machine learns something new, humans also learn about their own limits. Each time a model is wrong, we are reminded that knowledge is not immutable. And each time we make it better, we realize we are not just building technology but refining humanity's own cognitive capacity. If there is one message to take away, perhaps it is: don't fear AI, fear ceasing to learn. Because AI will never surpass humans who continue to learn. It will only surpass humans who have forgotten how to learn. And in a world where data changes every second, curiosity is the most sustainable asset. So, before closing this book, ask yourself, if there was a system that could learn from all your actions, what would you teach it first? And if it learned how you make decisions, would you be confident in those decisions? That is not just a question for AI's future, but a question for your own future.